Hello guys, welcome back to John's Workshop, and in this video we're back onto the milling machine head refurbishment again, and this is part 3 or part C in the trials and tribulations of getting my pinion shaft to match my new ISO 30 quill that I'm trying to fit into the milling machine. So part A was me making a royal cock-up of trying to rework the existing pinion shaft and scrapping it. Part B was me turning a brand new shaft from scratch, and part C is when we're going to move to the milling machine and we're going to mill the gear teeth into the pinion shaft and finish one or two other bits and pieces, features, turned features and milled features on the shaft, and hopefully get it all refitted back into the machine. So without any further babbling, hopefully if you've already watched part A and B then you know what we're doing. If you've not, probably worth going back and checking those two videos out to put this one in context. So I'll join you very shortly on either the lathe or the mill, can't remember, and we'll crack on with the first part of getting the shaft finished off. Okay, that's us all set up, ready to rock and roll. Again, if you want to watch that setup and see how I've done it, go back and watch part 4A. So I'm not going to go over that again. What I am going to do is just quickly discuss this divisions thing, which is how I managed to cock it up last time, and I know why I did, but there were several comments and I found it quite strange as well why I was winding the handle clockwise for my increments, but I was winding the sector arms counterclockwise. And lots of people were saying that that's really strange, you shouldn't do that, you should wind the sector arms in the same direction as your handle, and that's how I thought it was. So I've just done a double check, and with the sector arms I need to get 42 holes on this 49 hole plate, and with the sector arms fully open in their for the widest position they'll go before they lock up, I can get 38 holes on the 49 plate. So clearly not enough in between the two sector arms. And as I said before, the book for this particular rotary table, dividing head, gives you two ways of actually doing your divisions, and the top row is conventional, where you wind your sector arms round in the same direction as your handle, and the bottom option, which is the option I used, is where you wind your sector arms counter to the direction of rotation of your handle. And that's what I've used last time, that's what I'm going to have to use again. The only thing I got wrong was, because of that slightly confused me, and I counted the wrong number of holes by one hole between the sector arms. So we've got it all set up. Basically between each division, the way it works, it's a bit bizarre when you're used to working between the sector arms the other way. So basically I'm set up there now. I'll come out of that, I'll do my 2 full turns, so all the way around once, all the way around twice, and then when I come in for my 42 holes I then drop in to that inside sector arm and then wind the sector arms counterclockwise until this sector arm touches the pin, and then my next index will be 2 full turns, and then I'll drop into this hole. And that's the way the book tells you to do it, so that's the way we're going to do it. Okay, so the good news is this time round we've got our spacing correct, and I knew that was going to be the case because I did a sample part up front in a bit of Delrin just to make sure everything was working out okay. So we've taken our first depth of cut as we thought we needed to go deeper. So the good news is everything's calculating out around the periphery. The bad news is it's a bit tight in against the rack in the head. So what we've done now is we've set this all back up again in the machine. We've clocked everything back in the same way. I've had my cutter out. This is starting to show some signs of wear, so we've had that out, and we've very carefully stoned the flat face cutting edges on all the teeth, and we've loaded that back in. And what we're going to do now is set this back up into one of the teeth, and again I won't be able to film that because I'll need to be stood exactly where the camera is just now, so I've got line of sight down here. And then we're going to go back in and we're going to take another 20 thou out of each tooth all the way round. Okay, so we've taken our shaft back out the machine. We've cleaned out all of the teeth. There's a bit of deburring I need to do, but they're well stuck on. There's nothing loose that's going to drop off. So, moment of truth. Was my 20th hour educated guess good, bad or indifferent? So I'll just reposition the camera. We'll stick it in the side of the machine. In fact, I think you can probably see enough. We'll just do it where it is. Well, that's a good start. The shaft goes all the way in. Let me just pan out a little bit so you can see a little bit more what's going on. So that's the shaft in place. So I'm just going to let go of the lock. Hopefully I can hold this shaft tight enough to stop the spindle dropping under its own weight, if it's going to work. That is, because it just got locked up last time when I let go of it. It works. It is still a little bit tight. You can just feel it notching over the teeth as it goes down. I mean, there's no spring pressure holding this back at the minute. I'm going to clean that up. I'm going to clean that back up now. Just get the sharp edges and stuff off, and put a bit of grease in there, and then we'll refit it and just see how that feels with a bit of grease in and with all the kind of sharpy edges off. I think I'm almost going to leave that as is for now and see how we get on. We'll see what it feels like with a bit of handwork. Happy days. So we've got our shaft back in the lathe now, and we need to finish this end to length back to this face that we know we controlled from the other end of the shaft, which is down in the headstock. And what I'm using, and I use this a lot on a 3-jaw chuck when I want to not mark up. So this is the main bearing diameter that's in the chuck, and I use bits of shim. So this is 0.1 of a mil thick shim stock, and in a 3-jaw chuck, very useful. If you're putting copper in and bits of aluminium and goodness knows what else, they comply with the chuck jaws and they get chewed up, and you'll never get anything that runs anywhere near concentric in a 3-jaw chuck. Fine for a 4-jaw chuck, but 3-jaw not very useful if you want to try and keep things concentric. So as I say, I use the shim stock. So I'm just going to bring my clock in now, and we'll put it on center, which is there. And that's another thing. I see how quick that was to set that up, and how much more rigid this is. And if you look at there's lots of YouTubers have done videos on, in fact I think Mr. Crispin put one out only last week, different application, and talking about bar sag and sagging of indicators. If you look at this indicator, the way it's currently set up on my table, in terms of how gravity is going to affect it, the actual bar that the clock is attached to is vertical, so gravity effects and sag 0. And how quick and easy that was to set that on 0. So simple. These things are a godsend on the lathe. I use it all the time, far more preferable to a mag based clock. Very quick and easy to set up. So we'll just spin the chuck round, see what we've got. So that's a 1/10 of a thou indicator per division. We've got about 1 division, so that's running within 5/10 of a thou at that end. More than happy with that. So we'll get set up now to face to length, and then we've got to drill, tap, and then drill a bigger pocket, which is the spring pocket location in this end. Okay, we switched the part round, same deal, got my 0.1 shim stock in the chuck, same deal with the clock. I'm just going to bring that in, we'll zero out, Camera's a bit in my way. There we go. And we'll just rotate the chuck, whether you can see that. So about the same, one division, 5/10 of a thou. What we've got to do on this one is gently face, there's a tiny little bit, I need to face off the end back to my datum face that I've already done, that I used for all my drops when I turned the shaft. So we've just got that little bit to clean up, and then we've got to drill and tap an M6 hole into this end. Okay, so in the chuck we see exhibit number 1, which is the bearing, cast iron bearing from the small end of the shaft. And I made a mistake when I turned the shaft, assuming what I should do is just copy the original shaft, which any reasonable person would probably think that's the right thing to do. However, on fitting it I realised that it's a bit wiggly waggly in this bore. So I measured this bore up, and it turns out that it's about 0.2 of a mil bigger than the diameter on the original shaft. Now whether that's by design, which I doubt, or whether it's just sloppy fit, bearing in mind the surface finish in this bore looks like it's been put in with the top end of a pineapple, I think I'm going to assume that it's not very good. So what we're going to do is bore that out bigger. I've got enough meat to do that. And we're going to make a little brass bush up. We're just going to knock a little brass bush up, press it in, Loctite it in, and bore the bush out to be a good fit on the end of the shaft that I've just turned. So that's what we're going to do. While we're about it, we might as well make a decent job of it. So same idea, got my favourite clock stand that I keep going on about and I keep using, just to show you again how easy this is. Just drop that in there, wind on, find the lowest point, set 0, that easy, no droop, no sag, nice and simple. And that is reading about, well, in that crappy surface finish it's reading about just under 2 divisions, so that's within a thou. It's 5/10 per division on that clock, so I'm going to take it that's good enough. So I'm going to get a boring tool set up and we'll chew some metal out of there, enough to give me 2mm a side, I think, something like that, wall thickness for a brass bush to go in. So I'll bring you back when we're doing that. Okay, we've got our degreased bush. You'll notice I put some grooves in the outside, deliberately so, for retaining some Loctite. I'm using 638. Got our degreased casting, and it's a sliding fit. I didn't want it mega tight because I want the Loctite to have something leave some Loctite in there in the joint. Okay, we're over at the mill. We've stripped everything down, cleaned everything up, and we've got our vise back on and clocked in. We've got our shaft held in a V-block with a backing parallel to make sure the V-block doesn't tip. A piece of aluminium at the front to try and stop us marking the shaft with the hard vice jaw, and a screw jack under this end for support. We've set it up deliberately this way on in the mill, so we've got a keyway to mill in this end, and then I've got enough x-axis to get right down to the other end, and we've got a hole to drill and tap through here. So two separate operations, largely two separate setups. So even though I've clocked my vice in, because of all of this paraphernalia going on in here, I will reset up my shaft centre line when I get down to this end. So the next job, I've got my wobbler in the chuck. I'm not going to film that. There's so many videos of people using one of these edge finders to find centre, so I'm going to get centre found, get my position, get a tool loaded up, and we will proceed with putting the keyway slot in. That's going to be challenging. I've got no quill for obvious reasons, so I'm going to be needing to wind my head up and down to plunge in and do this. And the hard part about that is there's absolutely no feeling at all, and especially when I'm drilling a tiny hole in this end, we're going to be trusting quite a bit to luck. So I'll bring you back when we're doing that. Okay, we're all set up at our other end, and we've got an M4 hole to put in here that breaks through the first half of the shaft into the centre hole. So we'll crack on with that now. So you'll be pleased to know I've decided against power tapping M4 and trying to wind the head down at the same rate as the tap's going in. So we'll just stick with this nice simple manual method using the tap follower, which has been an absolute godsend when I made that for jobs like this. Well, there we go guys, that's the finished article. So we've got our shaft complete, we've got our 4mm hole, Got the tapped hole in that end for all of that's for spring tension and holding the spring in place. Got our gears cut, look reasonable. The rest of the shaft diameters, as you've seen, the keyway and the spring location and the threaded hole to hold the hand wheel on. So what we'll do now is ready the machine for fitting that. So I'm just going to take the drawbar out, take the collet chuck out, and then drop the spindle. We're going to put some grease in the rack, hold up the inside of the rack, and then pop that back in, and then we'll stick this in and see what happens. Okay, we've got everything greased and oiled up in the bearing diameters and in the rack. Probably going to have to there we go. That's our shafting. We're located nicely in this bearing, and I'll just go handheld. Come around this side. Should be able to see, it's a bit dark, but the brass bush that we've put in at this side. So what I'm going to do now is get the rest of the machine put back together. We're going to get the spring unit back on here, get the other casting on and the hand wheel, and I'll bring you back. Okay, we've got our hand wheel back on, spring back on. I've still to put all the front plate back on, but largely we've got a very nice quill back again with the ISO 30 spindle in it. So happy with that. We'll need to give that a bit of a test now. I need to give it a bit of a try. So obviously I've done some machining with this spindle, but all with it kind of fixed and locked with the lock, and using the head for my up and down. So I've done no quill work at all with this ISO 30 spindle, and now we've got it in the machine and usable properly. I've now got quite a bit of work to do in terms of getting my keyless chuck transferred over from Morse Taper 4 to ISO 30. I've got all the bits, I just need to do the work. I've got a couple of drawbars to make because some of the ISO 30 attachments that I've got, such as my clocks and holder, and I think there's one other, I think there's two, I think I need two drawbars in total. I think I need the standard one and another one, and there may be one more, I can't remember. So I've got at least one drawbar to make, and the next job then is to start getting myself kitted out with some more ISO 30 stuff. I've got a few bits. I bought a couple of face mills that I want to try, and I also desperately in the whole workshop, not just on the mill, need to do something with storage, because I'm just tripping up over stuff everywhere. I've got too much gear and not enough space, so I've really got to rethink the workshop, and that's probably going to be a few of the upcoming videos, as well as back on the shaper, because I'm just falling over myself over gear everywhere. So I'm going to have to try and do something with storage, and obviously as part of that I want to do something with my storage for my new ISO 30 tooling. So with all that being done and said, pleased that we've got this back together. I'll bring you back to the board and we'll close this episode out. Well, there we go guys, a bit of a marathon that was, and if it wasn't for a mistake we could have been there much sooner, but anyway, there we go. That's all part of the learning curve. So yeah, I'm pleased with that. I've enjoyed that actually. That was probably, I think, certainly from a turning and milling perspective, the most technical thing I've probably taken on, certainly for a while in the workshop, if not since I've set the workshop up. And prior to that, in terms of manual machining, we're probably talking the best part of 25, 28 years since I've done work of that standard on centre lathes, milling machines. In terms of gear cutting, I don't think I've ever cut a gear before. You know, it's just the industry I've been in, or industries I've been in, I've never needed to do that, so that was probably a first for me. And you know, again, using the dividing head, as I said in the video, not done that for 25 plus years probably. So yeah, it's, you remember some stuff, but really learning from scratch on some of this stuff, to be honest. I understand the principles, but you do forget some of the techniques and some of the methods, so and valuable lessons help you remember them as we've just found out. So I've just noticed I've still got my glasses on, safety third. So hope you've all enjoyed that, and it's been good fun. I've enjoyed that. It's been a good challenge of my memory, skills, machines, tooling, kit and all the rest of it, and proving to myself that, you know, not only me but my kit in the workshop has the capability to do jobs of that nature, which is, you know, which is good, because at the end of the day, you know, this is alright, I've been at this 2 years, but I still see this as a newly set up workshop, and I'm still setting it up largely, and that's why we're doing work on machines and various other bits and pieces. So yeah, it was a good project. So more to do on the mill eventually. We're not stopping there. We're going to keep going backwards and trying to make the thing as good as we can over time. So I hope you've enjoyed that. I hope you've enjoyed following along with the mill head upgrade, and thank you to the subscribers and the new subscribers that have come along, and we'll catch you all very soon on another video when we'll be making something else.